This. All right. Welcome back, everyone. This is week 4 of Intro to Backend. And happy first day of snow to everyone. Um, yeah, I hope it's not too cold for everyone. Let's go. So some announcements. So PA1 grades are out already. You should be able to see them on CMS. The median and average are posted on Ed, so you can check those out as well. PA3 is due already tonight. PA3 is due, and PA4 will be due next Monday, as usual. Here are some like advice for everyone like implementing their assignments. Like remember to double check your route spellings, testing in Postman, writing the test script, and just following the API spec and assignment handout. So yeah, hopefully everyone's been doing that. So today, as I promised, this is our last time. Actually, not the last time. This is the day we're going to be taking on SQL. So we're going to be replacing SQL, not replacing, but like covering that up with something called an ORM. And yeah, you guys won't have to write any more SQL from now on. And yeah, let's get into some review before we learn about ORMs.
Okay, so this is kind of what we've seen before. So we have a client, a server, and database. You can only see the server and database here. But whenever the client wants to add to get information, wants to update information, or create a new row in the database, it's going to call an endpoint to the server, and the server is going to query an SQL command to the database. The database is going to process that command and return the data. And we also learned about relationships. So this is how we relate data to other data in a structured manner. And we use foreign key columns to create relationships. And we have 3 different relationships. We're going to go through them really quickly. So the first one is one-to-one. So for example, we have a user table and a profile table. And you can see in the profile table, the user ID column is a foreign key column. So whenever we look at, for example, the second row in the profile table, user ID 10 refers to the ID in the user table, which is Lauren. And then you can see it's the same for the other rows. And then for one-to-many relationships, we have an album table and a song table. So an album can have multiple songs, but a song can only belong to one album. So as you can see, there's multiple rows in the song table that refer the same album ID. And you can see for this album as well. And then the last relationship is many to many. So we have a student table and a course table. A student can be in multiple courses, and a course can have multiple students. So to kind of model this relationship, we have a join table, which has the student ID and course ID. So if we're looking for all the courses that a student is in, we can look at the student ID and then look in the join table for that specific student ID, and we can see all the course ID that that student is in, and then we can then refer to the course table for the specific titles of that course. And then if you're going the other way around, if you want to see which students are in this specific course, CS 1110, you just look at the join table for that course ID, and then you can see all of the student IDs that are in that course here. Okay.
Right. So, oh my gosh. So now we're going to go into like the drawbacks of SQL and why it can be sometimes really messy and why we're actually moving away from it. So pain points of SQL, it's harder to read the code. If I give you like a page just full of SQL like this, sometimes it's really tough to tell what this is doing. Because you have things like inner like nested queries. So like you can see this is select from blah 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 blah. But inside that you have a select here, from here where, and then you have a group by blah blah blah. So there's a lot of syntax and a lot of um things that can go wrong by reading and trying to debug code like this. So that's why SQL is sometimes difficult to read. I've personally seen SQL files to run like one single query that can go up to like nearly 1,000 like lines. So yeah, those are really scary. And they're also susceptible to vulnerabilities, as we'll see in a in an example soon. And sometimes the runtime exceptions are not handled well. So remember last time we had constraints where you want to have like one-to-one. Each student can only have like one profile, for example. If you have more than one, then you get run into an exception, and then sometimes if you don't handle it, your program can crash. So SQL is good. I'll talk about why it's good later on and why we still use it, but these are the pain points we'll focus on for now. So, the vulnerabilities. So number one is a SQL injection. You can actually like craft some clever input to try and trick SQL semantics so you can like gain access to a database. And what this does is you can allow like unwanted parties, unauthorized access to your database, and they can like do things like corrupt or delete your database data. So let's walk through an example of what a SQL injection actually looks like. So we're going to be trying to break a login with SQL. So imagine you guys have like a users table, and for now, we haven't teach you guys like authentication, which is like storing password and stuff. But imagine you have a table with just like usernames, emails, and passwords, just stored like that. And let's try and break into the system. So this is your login. You have an email and password. This is how a query might look when you are trying to log in. So you put in your email here. Let's say my password is backend. And then I want to get the user item based on my input. So I'm going to select from the table user where my email is this and my password is this. This is just like a really bad way of storing users. But let's just say this is our system. And what this will give me back is it will give me a row in the user table where it's my user row. So this actually, like if you enter a wrong email and a wrong password, then you might get like false and false. And false will evaluate to this false, right? If you have like true and false, like my email exists in the database, but my password is wrong, then it might be true and false. And true and false will evaluate to false. So the only real way to like gain access to the database if you have both the email and both the password are true, which is like what we expect, right? And here's the interesting case. So you can actually input something like this into your password field, and then it will look as if you input this into your database. So initially it was like password and you put everything inside the password braces here, but now we have like XXX and then you add like a apostrophe there. That will close the string here, right? And then you continue. You put a space or 1 = 1, and it will add an or to your query. And we'll talk about why it's 1 = 1. Then afterwards we have this thing here, which will just actually forgot what this does. But yeah, we'll talk about this a bit later. So what this does is we add an or here and we set it to true. And false or true, it's an or, so it evaluates to true. So that becomes false. False and false or true. That becomes a true. And then false or true, that will evaluate to true. So even if your email is just a random email, it evaluates to false. So let's say your email, like from here, your email, let's say it's like a random email. Even if the email is wrong, it will evaluate to true and gain access to the database. Yep. So once you get that where true, essentially where true, you can just cover all of this up, and then you just get select all from user. So this way you can just gain access to all the users in the entire database by injecting like this string into the password. Yep. And then yeah, what happens is like your database and your backend will get like you let a worm inside the database and everything goes wrong. Yeah. Does anyone have any questions about that? Yeah.
Wait, why does it become like false or true?
False or true?
Wait,
Like at the end?
oh wait, because go back.
Okay.
Yeah, like how's
Oh
that?
yeah. So I think that's like this part is wrong, but like and takes precedence, so you do false and false, which is false, and then false or true, just true.
Oh,
Like,
okay.
don't.
Oh, this is my mistake. Wait, this should be like, oopsie.
Yeah, so false and false is just becomes false because and takes like precedence over or. So you look at the and first. So false and false is false, and then this is false. So false or true is true.
Yeah.
Does that make sense?
Got it.
Good catch. That's a very good question. False and false is false, and then false or true. Yep, is obviously true. Nice. Any other questions? This will not work in like any like public app because they definitely do not store passwords like this. But if you like do, then this is what a simple SQL injection looks like. And yeah, you can gain like access to the database. And the reason why we had the 1 equals 1, because that's just true. 1 is always equal to 1, so that's how we get the true in the last part. Okay. Let's skip this. All right. And the solution to SQL is we're going to introduce you guys to object relational mapping. So does anyone understand this reference I put here? I'll give an egg to anyone who can explain the reference. This is not related to backend. This is just like a funny meme I put in case anyone does. There's no. Yes, exactly. I'm gonna give you an egg for that. Oh, sorry. My bad. Wait, so yeah, so his name is Orm. Like in Aquaman, if you guys watch like DC Aquaman, like the bad guy, his name is ORM, Orm, King Orm. And that's like ORM, object relational mapping. So yeah. Uh I'm glad at least one person got it. Yeah, so what is object relational mapping?
So let's break this down. So we have object, which is any normal programming object that you've done in the past class, and then relational, which is all the tables in your database. And basically, we're mapping the objects to these tables in the database. So just think of it as you're representing tables as Python objects. So that's like where object relational mapping, the term comes from. And basically, these objects are as abstractions. So we're trying to abstract away from these SQL queries and query and manipulate data using objects instead. And we're still preserving the database for SQL and storage benefits. And it still allows us to reason about entries as instances of an object. So basically, think of it as like a table in the database is equal to a Python class. And whenever you make like different instances of that class, those are different rows in the table. So that's basically the gist of object relational mapping. And then this is kind of a side by side. So in SQL, we're creating a table called user, and we have the ID column, the name column, the age column. And then in an ORM, we're going to create a class or like a model called user. And all of these are like field names, right? These represent the columns in your table. So we have an ID field, a name field, age field, and we're defining them as a column. And for the ORM, we're going to be using this class. Sorry. Oh. We're going to be using SQL Alchemy. And this is a popular ORM for Python. And since we've been coding in Python, we're going to use our ORM in Python as well. And it comes with built-in query patterns and integrates really well with Flask. So some benefits with ORMs is a lot more readable code that more closely resembles our thoughts, and it's abstract, SQL-free data representation, same language database, so Python, and application logic, under the hood connection handling, and secure against SQL vulnerabilities that Josh just talked about. So some of the drawbacks is that sometimes it's slower performance for more complex queries. It also increases the application code. So this means that like when you're importing SQL Alchemy as a package in your application, that package has a lot of code inside. So in total, your application code is quite a lot. and it abstracts away from fundamentals of SQL. So this leads to potential for misuse because it's too abstract. For example, if you're using an ORM, but you don't know like what's going on under the hood, like you don't have a good knowledge of SQL and like how that works, you might misuse it or make it more complex than it has to be. Yeah, that's basically it for ORMs. Now we're gonna go into a demo.
And before the demo, I just want to draw another diagram to show you where ORM would fit in our entire stack. So again, let me just finish drawing this. So this is the database. Once again, it's just like todo.db, for example, which is like db. This selects that, returns it here. Move back to the I have something else. Okay, I think this is good. Yeah. So remember from last time, there's a similar diagram I drew. The user will like send a GET request, for example, to our server, and our server has app.py and db.py, right? This is a GET request. And then what we did was we had all our logic in db.py. Like right here, we have like a get task function, and then it will run like select all from task, like here, and then it will query the database, which is our todo.db file, and then it will send it back, and then it will send it to app.py, which will give it back to user. Where the ORM will fit is, wait, this is a function. Where the ORM will fit is instead of SQL, instead of this, we're gonna write a function just like, I forgot the syntax, but it'll be much simpler. Essentially, someone made a package, someone made an ORM. It's just like a Python package that you can like add here. For example, this is like SQL Alchemy. This is the entire package, like has like thousands of lines. And what that does is it allows us, instead of writing raw SQL, we can do like task.get. Like all we have to do is call a function in like SQL Alchemy syntax. So this is like, it's like a package built by whoever made SQL Alchemy, and it allows us to skip the SQL and just write like Python syntax. So that's what an ORM, like this is what an ORM does. You can stop writing SQL and you can do something like this. Does that make sense? Okay, let's start coding.
Does anyone have any questions?
Why is this so big?
Oh, so that people who watch the YouTube video can see.
Wait, why is it the same sentence? Yeah. Right. So let me just explain let's just explain. Better not touch this if we like disconnect it. Yeah. Yeah. Our app.py and db.py, we have the same two files again. In this case, we have this should be to do. We have something different. We have these app configs. So there's configurations for the app. And what these do these are just things to help configure our ORM, which is SQL Alchemy. It sets the database URI. It sets it to track. It's like track modifications. We set it false because we don't deal with any of that for this course. And then SQL Alchemy echo just means that it's just more verbose, and verbose as in like we get like the error logs when we're using our ORM. What else? This looks good. Okay. And then, yeah, this is the new syntax we have here. This, I'm just going to write a comment. This initializes the database. I'm going to turn off my code completions. Yeah. So, this 3 lines is how we use SQL Alchemy to initialize a database. Remember how last time in our DB, we just made a init function in our class to like create all our tables. In this case, we just call that. So no SQL, no like create table if not exists, blah, blah, blah. We just do this db.init app. And app right here was our Flask app, right? Flask is our framework. And then with app context, we just db.create all. So this will create all our tables basically. And let's continue. Does anyone have questions about this? This is, I think, the syntax here will not be like the normal Python syntax because we're using a package. It will not be like SQL syntax. It will just be like learning how to use this package, if that makes sense. So yeah, let's actually implement our really quick success response. just to like generalize success response functions. So like last time we have like success response, we have the data here or like the text, and then code is 200 for default. And then we just want to return JSON that dumps the data and then the code like this. And here I have to import JSON. Yeah. And then let's make one for the failure response. So hashtag generalized failure response. This will just be failure. Code will be 404 by default, say, and then we're just gonna dump the error. So it's gonna look something like this, error, and then the data right there. Yeah. Yeah, again, these are just functions to like abstract away, like rewriting JSON that dumps. Instead, we just use these nice functions. Yep. And yeah, let's go into writing our first thing in db.py.
Okay, so as you can see, we imported SQL Alchemy, and that's basically how we instantiate our database. So we're going to build our classes here, which are equivalent to the tables that we've done before. So we're going to make a table class.
Last task.
And db.model just means that we're telling SQL Alchemy that a task is a model in our database. And basically a model is going to be a blueprint of the objects that we're going to be making. So now we're going to, let me just make some comments.
And just for reference, this is the same project as last time. This is a to-do list app with subtask. But then next, like in the next demo, we're gonna add another feature to this like to-do list app to make it even more, like even better. So yeah. Too many with. Yeah, so yeah, spoiler, we're gonna add categories like tags, like hashtags basically to our to-do list app.
We're giving the table a name, and then we're gonna define the columns, or in this case, these are the field attributes. So for the ID, we're going to make it a column, and then we're going to define this column as an integer data type. And basically when you're telling that you're telling SQL Alchemy that ID is a column, it gives you a bunch of attributes that you can use. So that's like everything in this parentheses are going to be all the different attributes. So the first attribute is we're telling it that it's an integer data type. The second one is we're going to say that it's a primary key. So this is the unique identifier. And then we're going to also make the auto increment to true. So these like attributes are already built into SQL Alchemy. We're just like saying that it should be true. Like it's all false by default, but we're just saying that primary key is true and auto increment is true. And then we also have description, which is also going to be a column. This time it's going to be a string, and we're going to make it not wait. Not nullable. Not nullable, which means that you have to have a description. And then done is also a column. This is going to be a Boolean. And then it's also not going to be like you have to have a field for done. Okay, so now we're going to make the init function, which basically initializes your object. So this is going to initialize a new task object whenever you make a new task. So we're going to have self, and then this new argument, which is quarks, Q quarks. It's just abbreviation for keyword arguments. So this is like equivalent to whenever you're like calling the post endpoint and you're giving it a description, like you're giving a body with the description. That's like basically how this is like the equivalent of that is like the body you're given and how you want to initialize the task. So this is initialize task object. And we're going to define that object's description. So for this, we need to access the body that we are given. And we're assuming that this body has a description key value. So we're using the body that we get in through the argument and then getting the description from that. But there's a chance that the client doesn't give a description, so we're going to give like a default description, which is just an empty string. And then we also have self.done, which is also from the body. And if we're not given a specific value, we're just going to make the default to false. Yeah. So that's our first model. Does anyone have any questions?
Yeah, so let me go more into like what this keyword argument is, because maybe you guys haven't seen it before. Essentially what this does is a special syntax in Python, where whatever you put inside this function, this init function, it will transcribe into a JSON. So to give you an example, let's make a new terminal, for example. This, let's see. So let me just go into Python. And in Python, let's say I have a new function called like hello. Here I'm gonna do the same thing. I'm gonna use this argument keyword arguments, and then I'm just gonna print that just to show you guys what it looks like. Yeah. And now let's call this function with something. So let's do like hello of, and here I can put things like name equals like Josh. I can put like mood, something like this. And then if I press enter, oh, I misspelled keyword arguments. Yeah, wait, let me redefine that function. The hello keyword arguments bigger in here. Wait. Then I'm just going to do, what was it? This printed for arguments. That. And then let's call it. So like hello name Josh. You can see that. This function like that. Yeah. So if I call that function, I can add as many like key value pairs as I want inside this like as arguments. And then when it will give me back, it will just give me back a JSON. So what this lets us do is like we don't have to use loops to do this. We can add like infinite amount of arguments, similar to how a body would work. Because in a body you can put like as many like keyword values as you want, right? So yeah. Does that anyone have questions about this? This is like some special syntax just for this use case. Okay. B. Okay. Yep. And yeah, okay. So now we have the initialize. So this is to create a task object. So we have the class, which is a table, and then this init function. This will like allow you to insert rows into your table. So you can insert new task by calling this init function. Right. Now let's add a serialize function. So what a serialize function is essentially you want to package the data before you give it back to the client. Like how last time we package it in a nice JSON format. This time we're going to do the same thing. So serialize will just taken self. What this does is it will serialize a task object. And all we're gonna do is we're just gonna return a what the heck? We're gonna return a dictionary. We have same syntax as last time. ID will just be self.id because in this case, like we're storing everything inside the object, so we can just like call the ID of the class self.id.
Colon.
I forget a colon. Yeah. Self.id. We have description will be self.description, and we have done is just done. I mean self.done. That. And every time we wanna like get the insides of like a task object, all we have to do is just call like the object dot serialize, and it will give us the ID, description, and done. So that's how we're gonna like get. Okay. Yep.
Okay. So that's all for our task model for now. We're going to add on to it next class, but we're going to define another model called subtask. So this is kind of the same thing as what we have here. So I'm just going to copy this. So we have our table name, subtasks. Our ID is the same. Our description is the same. Our done is the same, but now we have an extra attribute, or sorry, extra column, which is the foreign key. So this is how we connect subtask to task. So this will be an integer, and to define a foreign key, it's db.foreign key. And then inside here, we're referencing what table we're relating to. So that's the tasks table or model. And then we have to define what specific field or column. So here we're going to relate the task ID. So to define that, we're going to do tasks.id. And then we're also going to do nullable false. So it has to relate to a specific task that already exists. When you're creating subtasks, when you're creating a subtask, it has to belong to a specific task. So that's what this task ID is for. And then we're going to define the init function. And then again, we have quarks, which is keyword arguments. And then this is basically initializes our subtask object. So this is similar to our init function for task, except we have an extra column, task ID, that we're going to also get. Yeah. And then lastly, we're going to make a serialized function. So you should have a serialized function for every single model that you make. And this basically returns a subtask into a readable JSON. This is basically the same thing. So this is the same thing as task, except again, we're going to have a task ID. Okay. Does this make sense so far?
I have a couple comments. So you go to the task.id, Yeah, so this is your relationship, right? So like one subtask is like one too many. So one task can have many subtasks, but not the other way around. This is your relationship. It's again a foreign key, same keyword. But this right here, this string, looks a bit weird, but what this is this is the table name. So if you go all the way up to task, scroll to task, this table name right here. So make sure this and the like what you're referencing is same. Task right here, and then .id is just the name of the column. So there is a difference between what your class is called, which is task capital T, with what you give SQL Alchemy, which is this lowercase with an S. So there's a difference. Just remember that because sometimes you might get confused, like uppercase, lowercase, but just remember that what you're giving a SQL Alchemy is different from what you see on your pipe, like on VS Code, which is like whatever you name your class.
Yeah.
Can I ask why you do like a default value for like dictionaries for like descriptions? Because isn't it like non-nullable?
Yeah. So not nullable. If we put an empty string, it's still not null because it's an empty string. But we just put not nullable because like if you have like to-do list, you can't have an empty to-do list. That'd be kind of weird. Here, but here we allow it. So it's kind of, you're right, this is kind of a weird design choice. You should instead here add some error checking to like not allow that. But that's where we'll do the app.py. So in app.py, we're gonna check to make sure description is like it's there. But in the end, our db.py, like it will not return any errors. Like this is like the advantage of ORMs. It's like we can add this so like we don't get any errors. So even if our app.py like lets something go, like lets one of the descriptionless tasks through, then it won't throw an error. But yeah, we'll add that check in app.py, I believe. Question.
Okay, we're gonna go into the Kahoot now. Should I disconnect it?